Have you ever stopped to think about what's really going on inside your computer? I mean, you click a mouse, you tap a key, and magic happens. Well, today, we're going to pull back the curtain and look at the single most important part of that machine, the CPU, or as we like to call it, the computer's brain.
So, let's start with that big question. We say computers think and process information, but what's actually doing all that heavy lifting? It all comes down to a tiny, powerful chip with 3 little letters, CPU. Okay, so here's the textbook definition, the central processing unit. It's a little dry, right? But the subtitle here, the brain of the machine, that's what you really need to remember. Every single thing you do, from moving your mouse to loading a website, is a set of instructions that get sent straight to this brain to be figured out.
Now, this brain isn't just one big blob of thinking stuff. Nope, it's way more organized. Think of it like a small, super efficient team of experts, where each member has a very specific, very important job. So let's meet the team.
First up, we've got the control unit, or the CU. This is the boss, the project manager, the conductor of the orchestra. It doesn't do the math or the logic itself, but it tells everyone else what to do, when to do it, and where to send the results. It's the one calling all the shots.
The control unit is basically the ultimate traffic cop for data. It grabs the instructions from your computer's memory and then just points, telling all the other parts, the memory, the calculator, your keyboard, you name it, exactly how to respond. It keeps everything moving smoothly.
All right, so if the control unit is the manager, who's actually doing the work? Well, that would be this guy, the Arithmetic Logic Unit, or ALU. This is the number cruncher of the team, the math whiz. This is where the real thinking happens.
And its job is split into 2 parts. First, it does all the basic math you'd expect, adding, subtracting, the works. But the second part is what's really amazing. It handles logic. Every decision your computer makes, like, is this number bigger than that one, or does this password match? It all boils down to a simple true or false comparison made right here.
And the last key member of our little team is the registers. Now, these are tiny, but unbelievably fast little bits of memory that live right on the CPU chip itself. This is the CPU's personal scratch pad.
You know, this is the perfect way to think about it. Your computer's main memory, its RAM, is like a huge bookshelf. To get something done, the CPU has to go find the right book. But registers? They're like sticky notes pasted right on the desk, holding the exact piece of data the ALU needs for its very next thought. It's all about instant access.
So, we've met the manager, the calculator, and the scratch pad. How do they all work together? Well, they perform a simple 4-step dance. And they do it over and over and over again at a speed that is just mind-boggling. This is the heartbeat of your computer.
And when I say mind-boggling, I'm not kidding. A pretty basic 1 GHz CPU can perform that 4-step cycle 1 billion times per second. In the time it took me to say that, it did it billions of times. Modern CPUs, they're way, way faster. It's just incredible.
And this is that dance. First, the control unit fetches an instruction. Then it decodes it to understand what to do. It sends it over to the ALU to execute the command. And finally, the result is stored. Fetch, decode, execute, store. That's it. That simple loop, billions of times a second, is literally everything your computer does.
Okay, so that's the theory, but how does this help you in the real world? You know, when you're looking to buy a new computer and you're just bombarded with specs and numbers, let's break down what actually makes one CPU better than another.
It's the big question, right? Is it all about that gigahertz number, or is there something else going on? Well, as you might have guessed, it's a little more complicated than just one number. It's really a team effort.
So these are the 4 big things to look at. You've got clock speed, which is how many cycles it can run per second. Then you've got cores, which are like having multiple CPUs in one. Threads help manage tasks for those cores, and cache is like a bigger, faster set of sticky notes. But for right now, let's just focus on the big 2, clock speed and cores.
See, for a long time, CPUs only had one core, one brain. To make things faster, engineers had a brilliant idea. Why not just put multiple brains on one chip? And this shows you why that's so awesome. A dual-core CPU can literally work on 2 different things at the exact same time. A quad-core can do 4. This is what lets you stream music while you're writing an email and have 20 browser tabs open without your computer just giving up. And here's the simplest way to remember it. Think of it like a kitchen. More cores is like having more chefs, so you can cook more dishes at once. That's multitasking. A higher clock speed, the gigahertz number,
is like having each of those chefs work incredibly fast. You really want a good mix of both for the best performance.
Okay, let's get back to the real world. When you walk into a store, you don't buy a CPU, you buy an Intel Core i7, or an AMD Ryzen, or an Apple M2. So let's quickly sort out who's who in the zoo.
For years and years, the world of PCs has been a battle between two giants. Intel, with their famous Core i-series chips, and their big rival AMD, with their Ryzen chips. But lately, Apple has totally shaken things up with their own super-efficient M-series chips. And that phone in your pocket? Odds are it's running a chip designed by a company like Qualcomm.
And the reason they're all different comes down to this. They're built on completely different architectures. Think of it like two different languages. Intel and AMD use x86, which is all about raw power and performance, perfect for a big desktop computer. Apple and most mobile chips use ARM, which is designed from the ground up to be insanely power efficient. That's how your phone can last all day on a tiny battery.
So at the end of the day, it all comes back to this one idea. It doesn't matter who makes it or what language it speaks. The job is always the same. It's this one, tiny, complex, beautiful piece of engineering, the brain, working tirelessly to make all of our digital lives possible.
So if you remember anything from this, remember these four things. 1, the CPU is the brain. 2, it's got a team inside, a manager, a calculator, and a workspace. 3, it works in a simple 4-step cycle, billions of times a second. And 4, its power comes from a mix of its raw speed, or clock speed, and how many tasks it can juggle at once with its cores.
And that kind of leaves us with one last really interesting thought. We started out by building a single computer brain. Now we're putting 8, 16, even more of these brains onto one chip. It's starting to look a lot like how our own brains work. So you have to wonder, what comes next? What's the next great leap for the brain in the machine? Something to think about. Thanks for joining me.